lesson 1. So here we are at a bagel shop, and we have our cost of fresh bagels, okay? And a customer at a bagel shop is buying 13 bagels. The shopkeeper says that would be $16.25. Jada, Priya, and Han, who are in the shop, all think that this is a mistake. Jada says to her friends, shouldn't the total be $13.25? Priya says, I think it should be $13. Han says, no, I think it should be $11.25. Explain how the shopkeeper, Jada, Priya, and Han could all be right. Okay, so take just a little bit of time and think about how all of these could be correct, and then we'll go over some solutions for that. So the shopkeeper multiplied the price of one bagel by 13, which gives $16.25. So the shopkeeper takes the price of one bagel, which is $1.25, okay, multiplies it by 13, okay, which is how many bagels are purchased, and that's going to give us $16.25. Okay, so the shopkeeper could be right there. For Jada, Jada multiplied the price of 6 bagels by 2 to get the price of 12 bagels, which is $12, and then added the price of one bagel, which is $1.25, to get a total of $13.25. Okay, so up here, it's kind of like we're getting a discount if we buy more bagels, right? So what Jada did is took the price of 6 bagels here, multiplied it by 2, that's going to give us 12, and then added the price of one bagel. Okay, so that's how Jada went about finding the cost. So Priya started with the price of 9 bagels. Okay, so the price of 9 bagels is right here, which is $8. And then added the price of 4 individual bagels, okay, which is 4 times 1.25. So she took this times 4 and then added them together. So the total would be $13. And then finally, we have Han started with the price of 12 bagels, which is $10. Okay, so that's going to be right here. And then added the price of one bagel, okay, which is, let's go ahead and erase this so I can get rid of that. Okay, one bagel, which is $1.25, added them together to get $11.25. So what I've done over here on the right-hand side is I calculated the best price. So we can see, here's our one bagel, okay, from our menu. Here's our 6 bagels. Okay, here's our 9 bagel price and our 12 bagel price. So you can see that the cost goes down, right? There's a discount for each level here, all right? And then we're just going to take this $10. We're going to add that $1.25 for the last bagel, and then that's going to give us the best price of $11.25. Okay. So another way you can do this is you can look at a plot like this, and it will calculate or show you visually in a table how you can go about looking at these different values. Okay, and so we can see, right, that the shopkeeper's price is $16.25, Jada's price $13.25, Priya's price is $13, and Han's price is $11.25. So I'm going with Han. All right, that's the bagel calculation that I would want. All right, so let's look at the next one. Be right back. 3 days in a row, a dog owner tied his dog 5-foot-long leash to a post outside a store while he ran into the store to get a drink. Each time the owner returned within minutes. Okay, so we've got 3 days in a row, and then 5-foot-long leash. Now, we've got the dog's movement, which is described here. So on day one, the dog walked around the entire time while waiting for its owner. Okay, so the dog just walked around. Day two, the dog walked around for the first minute and then laid down until its owner returned. And then on day three, the dog tried to follow its owner into the store, but was stopped by the leash. Then it started walking around the post in one direction. It kept walking until its leash was completely wound up around the post. The dog stayed there until its owner returned. Each day, the dog was 1.5 feet away from the post when the owner left, and each day, 60 seconds after the owner left, the dog was 4 feet from the post. Okay, so we're going to look at all of those and sketch a graph that could represent the dog's distance from the post in feet as a function of time in seconds since the owner left. Okay, so let's take a look at our graph here. On the bottom, we have our time in seconds. Okay, that's our x-axis. And on the y-axis is the distance from post in feet. So the time in seconds along the x-axis, okay, this is called our independent variable. And up here on our y-axis, we have distance from post, and that's going to be our dependent variable. Okay, so the distance depends on the amount of time that has passed. So let's go ahead and take a look at these graphs. So on day one, okay, we see, or sorry, each day, the dog is going to start, okay, 1.5 feet away from the post. Now remember, the leash is 5 feet long. Okay, so at 60 seconds, right, the owner was 4 feet, sorry, the dog was 4 feet from the post. But we know that the leash goes to 5 feet. Okay, so at some point around here, when we are plotting the distance from the post in feet, okay, it starts at 1.5. It can go all the way to 5 feet. So the graph could look really different, okay, depending on, oop, that shouldn't go, that should just go to 5, sorry. Okay, so to 5 feet, and then at 60 seconds, we're at 4 feet. It could come up again. It could go down. So I'm just making this distance up, okay? Because we only have 3 constraints. Okay, our first constraint is where it starts. We can only go to 5 feet because that's how long the leash is. And we know that at 60 seconds, the dog is 4 feet from the post. So that would be day one. For day two, okay, we still have the same constraints, but now we also have the dog walked around for the first minute and then laid down until its owner returned. All right. So for this one, the dog walked around for the first minute and then laid down until its owner returned. Okay, so we're still here. Now, again, the dog is just walking around, okay, for the first minute, okay, and then we can bring it down and here. Okay, so now here is where we're at that minute, okay, and then we're going to lay down so there's no change, okay. Okay, I'm just doing that nice and thick so you can see that there's no change in distance after that minute. Okay, let's look at the next one. Now, for day three, The dog tried to follow its owner into the store, but was stopped by the leash. Okay, so for this one, we're going to start, maybe. All right, so we're going to start right here, remember, because that is going to be our constraint. Okay, it starts here. And then the dog is going to follow the owner in, okay, until the leash is going to be pulled tight, okay? And then we're going to go like this. Okay, so that's just going to be a straight line. Okay. Now, we also know that the dog, okay, is at 60 seconds 4 feet from the post. So we have to do this, okay? It has to go down to that point right there, okay? So then what happens? So what I was thinking, I was kind of like thinking about this. Here's our post, okay? And then here's our dog. Here's the leash, okay? And then here's our puppy at 5 feet. All right. Then it's going to keep walking, all right? And then let's say this right here is our 60 seconds, okay? And so that's going to be 4 feet. Now the dog is going to keep walking around that post, right? And that leash is getting tighter and tighter and tighter until the dog can't move. Now, we're not going to worry about the time. And then we're going to look at our distance at each one of these points. Okay, now we don't know what these other points are. That's okay. But we can see that the distance is decreasing. Okay, the distance is decreasing. Okay, remember, these lines are the distance. So the distance away from that post steadily decreases, okay, until the dog is like wrapped up right at the post. And so what that means is this is going to continue down like this because the distance, right, continues to decrease at a constant rate because it's getting wrapped up around that post. So this would be the way that you would visualize these different graphs. Okay, now, are you ready for more? From the graph, is it possible to tell how many times the dog changed directions while walking around? Okay, and then explain your reasoning. So I'll go ahead and type this up. So no, the graph only gives the distance from the post. The dog could change from moving clockwise around the post to moving counterclockwise around the post. We don't know which direction. We just know the distance. So these changes cannot be seen in the graph. All right. So let's look at the next one. Talk about a function. Here are two pairs of quantities from a situation you've seen in this lesson. Each pair has a relationship that can be defined as a function. Time in seconds, since the dog owner left, and the total number of times the dog has barked. Okay, so time and how many times it's barked, and time in seconds since the owner left, and the total distance in feet that the dog has walked while waiting. Okay, so these can be a relationship that can be defined as a function. So that's one of the words that we're going to learn. Choose one pair of quantities and express their relationship as a function. Okay, so in that function, which variable is independent and which one is dependent? And then write a sentence in the form blank is a function of blank. And then for the final one, number 3, sketch a possible graph of the relationship on the coordinate plane. Be sure to label and indicate a scale on each axis and be prepared to explain your reasoning. Okay, so let's go ahead and take a look at this problem. In that function, which variable is independent, which one is dependent? Okay, so usually, okay, most of the time, our independent variable is going to be time, okay, or time is the independent variable, is what I should have said. And so what that means is independent means it doesn't depend on anything else, right? It's just going to keep on happening no matter what we do, right? We can't stop time, can't change time, so time is independent of anything else, all right? Now, the times a dog barks, right, might be dependent on time. So maybe the dog barks a few times at the beginning, right, but then gets lonely and starts barking more and more and more. Or maybe the dog barks a lot right when somebody leaves, right, and then possibly starts to just be like, owner's not coming back. We'll go ahead and stop barking. So this one in the function, which is independent, okay, so independent is going to be, okay, and what we usually do is write IV, okay, and that's going to be time. And so dependent variable, or dv, is going to be dog barks, okay, or what would be better is number of dog barks, okay. So then we have write a sentence of the form blank is a function of blank. Okay, so what we can put here is the total number of times the dog has barked is a function of the time in seconds since the owner left. Okay, so the total number of times the dog has barked is a function of the time in seconds. Okay, we need to know that it's in seconds, because not minutes, not hours. Okay, since the owner left. Okay, sketch a possible graph of the relationship. Okay, so let's go ahead and we're going to have our time. Okay, remember that's going to be our independent variable. Our dependent variable is the number of barks. Okay, and then the time in seconds. All right, so let's do this. We don't really need to be specific about this. 40, 60, 80, 100, 120, 140, 160. Okay, and then up here, let's put 3, 6, 9, 12, 15, 18. Okay, so down here, okay, we got a couple barks. Maybe we have another bark here. Okay, we got 6 barks here. Let's go up here. We got a bark here. Got about 9 barks here. Put a couple barks here. Okay, then we got bark here. Okay, dog barks about 13 times. Go up here. Okay, barks about 15 times. Okay, so that could be a graph of how many times the dog barks. Okay, so that is just basically going to be for the first pair of quantities. Okay, that's time in seconds since the dog owner left and the total number of times the dog has barked. So let's look at time in seconds since the owner left and the total distance in feet that the dog has walked while waiting. Okay, so let's see, what we can do is we can just get rid of all this. Okay, and then we're going to look at the second one. Okay, so in this function, the time in seconds is the independent variable, and the total distance is the dependent variable. Okay, so now we're going to write a sentence. The total distance the dog has walked is a function of the time in seconds since the owner left. Okay, so down here again, we can put our time in seconds. And up here, we can put our total distance. Okay, so a total distance. All right, so this one's going to look a little different because we're going to have, whoops, that dog walking. Maybe it walks a little further, then doesn't. All right. Oh, I forgot to put my marks in here. Okay, and then let's say 5, 10, 15, 20, 25, and 30. Okay, and then let's have this be, I'll be a little bit more specific in feet. Okay, so the time in seconds, right? So at 40 seconds, the dog has walked a total of like 12 feet. Okay, at 2 minutes, walked a total of around, what, 27 feet. Okay, so this one is a continuous line because the dog is always going to be moving. Okay, or if it's not moving, we still have time that keeps on going. The barks that we had before are they're discrete. Okay, so you've got like bark, 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 right? You don't have like bark. Okay, that would be the difference. So remember to always take a look at the lesson summary, okay, because this is really going to help kind of clarify everything for you on that. All right, that is it for this lesson.